Okay, we're going to go through solving linear systems to elimination. So what's a linear system? Linear system is, this is our graph here, when we have one line, two lines. When they say solving a linear system, it's just finding the point of intersection between two lines, okay? We're going to do it algebraically. So instead of graphing it, we did a rough sketch there, we're going to use elimination. So this is a specific style to solving it. Okay, so first thing we're going to do is we're going to number the two equations just so it's a little easier to reference them as we go through this. So we'll call this equation 1, and we'll call this equation 2. Okay. And what we're going to do is we're actually going to stack them on top of each other, kind of like a subtraction question from like grade 4, you know, or addition. You know, if you had something like this minus this, we're going to stack them on top of each other. So I'm going to take the very first equation, equation 1, and it's going to be y is equal to 3x minus 2. Now, it just so happens, this is going to work out very nicely. What we want to do is line up variables and constants. So I'm actually going to rearrange this one here. Y equals 5 minus 2x. The reason we're going to stack them on top of each other is the hope is to line up things. Okay, so if we take a look, both my y variables are on top of each other. My x variables aren't, and my constants, that's a term that doesn't have a variable, aren't either. So I'm going to rearrange the one on the bottom. I know it was written this way, I just did that to show you that we can do this. So I'm just going to move it to the right again. So again, this was equation 1, this was equation 2. So equation 1, we have y is equal to 3x minus 2. And in equation 2, we're going to line everything up. So y equals, what's the x value? Negative 2x. And what's the constant? Positive 5. Perfect. So we now have constants lined up, x variables lined up, and y variables lined up. This works out wonderfully for us. What we're going to try to do now is eliminate one of the variables. So we're going to focus on either the x's or the y's. We can eliminate either one. I'm going to tell you, we're going to start with the harder pair. Okay, so I'm going to eliminate the x's. And in order to do this, we want to have the same coefficient. So that's the value in front of the x's. Right now we don't. We have a 3 and a negative 2. So I need to come and get a common multiple. So a common multiple between 3 and 2. Whether it's plus or minus, that doesn't matter. It's just the absolute value we're looking for. So a very quick way to do this is I know that if I multiply 3 times 2, I'll get 6. And if I multiply 2 times 3, I'll get 6. But when we do this, we have to do this to the entire equation. So if I'm going to create 6 by multiplying by 2, so 3 times 2, I also have to multiply the constant by 2, and we have to multiply y by 2. Okay? So I'm going to scroll down just a little. I think I am. There we go. So I'm going to say this is now equation 1 after it's been multiplied by 2. So 2 times y is 2y. So after we did 2 times y, we got 2y. 3x times 2 gives us 6x. And negative 2 times 2 gives us negative 4. Okay, so there's equation 1 times 2. I'm still going to write equation 2 the original way, just so we do it step by step. To get that same coefficient, so for our x values, I need to multiply this value by 3. So I'm going to multiply this by 3. But again, I can't just do it to one of the terms. I have to do it to every term. And you might be able to do this all in one step, which is completely fine. Okay, I'm just going to scaffold and make it one step at a time. 2y is equal to 6x minus 4. That's equation 1, which we've already completed. Equation 2 times 3 would read this. 3y is equal to negative 6x plus 5 times 3 is 15. Good. So we now have the same value here. I need this to create a 0. So this is where I'm actually going to choose my operation. In elimination, we can either add the two equations or we can subtract the two equations. It actually it doesn't matter which we do, but we just got to reach our goal of eliminating this. So would I add these values together or subtract them to create 0x? Whoops. Do you know what we would do here? If I want to create 0x, what would I do to 6 and negative 6? Would I add them or would I subtract them? To think about it. If we're unsure, we can just test it. Let's subtract. So 6 subtract negative 6. Do you guys know the little trick when things are written this way? We combine them. So it would be 6 plus 6. Does that create 0 for us? No. So let's do the opposite. 6 plus negative 6 What does that become, those two terms? Yes, 6 minus 6 give us 0? Yes, so we have to add them. That was the value we had there. So I'm going to add these two equations together, okay? So when we add them, we technically add everything. 2y and 3y, well, that's 5y. 6 plus negative 6, that's 0x. And negative 4 plus 15 is going to be positive 11. Now, 0 times anything is 0, and 0 plus anything is whatever the other number is. So essentially, this is gone. The x has disappeared. So now we have 5y equals 11. To isolate for y, we divide both sides by 5. And y is equal to 11 over 5. It's going to be some decimal, not value. I'm going to leave that as fraction. That's technically only one of the coordinates. Elimination can be long this way. So y is 11 over 5. What about x? Well, to solve for x, whoops, change this somehow. Okay, I'll change it. To find x, we have to eliminate the y's. Now, luckily, what's the coefficient in front of the y's? What's technically 1, and they're the exact same one. So we don't have to do any of this part here. We can just take them. So I'm going to take them again. Equation 1, y equals 3x minus 2, and y equals negative 2x plus 5. Okay. We need to make them 0. So what operation will we do? What gets rid of 1 and 1? Do we add them or do we subtract them? Subtract them, yeah. Okay, so we're going to subtract these. So here we added, now we're going to subtract equations. 1 subtract 1 gives you 0y. 3 subtract negative 2 is actually like adding it. So it's like 3 plus 2, so we get 5x. And 2 subtract negative 5 is the same as negative 2 minus 5, which is negative 7. So here we have 0 is equal to 5x minus 7. We're going to bring the 7 to the other side, so it's going to become positive 7. We're okay with that idea? It's the same as adding 7 to both sides. Okay, and that way here it eliminates, and we're left with 7 is equal to 5x. And to isolate for x, we divide by 5, divide by 5. The 5's eliminate, they create a 1. And x is equal to 7 over 5. So the point of intersection is two fractions. They're not very nice fractions. But that's the point of intersection between those two equations. Okay?